The ascension of Ramesses II to the throne of Egypt in 1279 BCE marks a pivotal moment in our alternate history. In our timeline, Ramesses would become known as Ramesses the Great, Egypt's most celebrated pharaoh, remembered for his monumental building projects, military campaigns, and unprecedented 66-year reign. But in this divergent world, where Egypt has already embraced steam power and early industrialization, Ramesses becomes something far more consequential, history's first industrial emperor. Unlike his predecessors who witnessed the emergence of steam technology as adults, Ramesses II was born into this transformed Egypt. From childhood, he watched steam-powered pumps irrigating fields, blast furnaces producing iron, and the first factories mass-producing everything from weapons to furniture. For him, these were not miraculous innovations but the foundation upon which to build an unprecedented empire. Ramesses' father, Seti I, had already expanded Egypt's industrial base significantly during his relatively brief reign. He established new mining operations in Sinai and Nubia, constructed shipyards for building steam-powered river vessels, and launched military campaigns that secured vital resources for Egypt's growing industrial appetite. But Seti's vision was ultimately conservative, using new technologies to strengthen Egypt's traditional role as a regional power. His son harbored far grander ambitions. The first decade of Ramesses' reign is devoted to internal development and consolidation. He orders the construction of a vast industrial complex at Pi-Ramesses, his new capital in the eastern Nile Delta. This city, strategically positioned as both a military stronghold and industrial center, becomes the ancient world's first truly industrial metropolis. Its layout reflects an entirely new urban paradigm. Residential districts are separated from manufacturing zones, canal networks distribute water, goods, and power throughout the city, warehouses and administrative buildings form an intricate logistical web. The skyline of Pi-Ramesses would be utterly alien to archaeologists of our timeline. Alongside the traditional pylons and obelisks rise the chimneys of foundries, the water towers feeding steam networks, and the giant wheels powering the world's first industrial mills. Yet these structures bear distinctly Egyptian aesthetics. Hieroglyphic inscriptions invoke divine protection, architectural elements echo traditional temples, and statues of gods and pharaohs stand watch over workshops and factories. Under Ramesses' direction, Egyptian engineers refined steam technology to a remarkable degree. The primitive engines of the previous century give way to more efficient designs. Double-acting cylinders, pressure regulators, and improved boilers all emerge from the royal workshops. These are not random discoveries but the result of systematic research and development, perhaps the world's first organized industrial R&D program, conducted by priests and engineers working in tandem. The most significant technological leap comes in transportation. Early in his reign, Ramesses commissions the development of reliable steam vessels for both river and sea travel. The first functional steamboats appear on the Nile around 1270 BC, flat-bottomed craft with paddle wheels and tall smokestacks, their hulls decorated with traditional Egyptian motifs, their prows shaped like sacred animals. These vessels transform Egypt's internal commerce, allowing rapid movement of goods and people independent of wind and current. By 1265 BCE, larger steam-powered ships capable of Mediterranean voyages emerge from Egyptian shipyards. Though still utilizing sails for additional power and as backup, these vessels represent a revolution in maritime capability. A journey from Egypt to Crete or Cyprus that might take weeks depending on weather can now be completed in days with reasonable certainty. Egyptian sea power, already formidable, becomes truly dominant in the eastern Mediterranean. The social transformations begun in the previous century accelerate dramatically under Ramesses. A distinct industrial middle class emerges: engineers, technicians, factory overseers, and skilled workers who occupy a space between the traditional elite and the peasantry. Literacy rates climb as technical knowledge requires broader education. Women gain new economic roles in certain industries, particularly textiles and ceramics, where steam-powered machinery reduces the physical strength required for production. Perhaps most remarkably, Egyptian slavery evolves along a different trajectory than in our timeline. While still present, particularly for domestic service and some agricultural work, mass enslavement for industrial labor proves inefficient compared to trained, motivated workers who understand the machinery they operate. Instead, a class of industrial workers emerges who, while not free in the modern sense, possess greater rights and protections than traditional slaves or conscripted laborers. They receive standardized rations, housing, and even primitive healthcare designed to maintain the workforce. the religious framework supporting industrialization also evolves during Ramesses' reign. Building on the synthesis achieved under Tutankhamun, Egyptian theology formally incorporates technological innovation as a sacred duty. Temple complexes now include industrial elements as a matter of course. Priests undergo technical training alongside religious instruction. New religious texts appear, manuals that are simultaneously technical handbooks and sacred documents, explaining both the physical principles and divine aspects of steam power, metallurgy, and mechanical engineering. Ramesses himself embraces a theological identity as the divine embodiment of industrial progress. In his monuments and inscriptions, he is depicted not just in traditional poses smiting enemies or making offerings to gods, but actively engaged with technology, operating steam machinery, inspecting metalwork, even drawing technical diagrams. The message is clear: mastery of industry is now central to pharaonic authority. By the 15th year of his reign, with Egypt's internal industrial base firmly established, Ramesses turns his attention outward. The military applications of Egypt's technological advantages can no longer be ignored. Iron weapons, mass-produced in Egyptian factories to standardized designs, give his armies overwhelming superiority against bronze-armed opponents. Steam-powered logistics allow the rapid movement of troops and supplies. Even early experiments with steam-powered siege engines begin to appear. The Battle of Kadesh in 1274 BC, which in our timeline was a near disaster for Ramesses, salvaged into a propaganda victory, becomes in this alternate world a decisive Egyptian triumph. The Hittite Empire, Egypt's principal rival for dominance in the Near East, encounters not just conventional Egyptian forces but the world's first mechanized army components. Steam-driven supply wagons keep Egyptian troops well-equipped. Iron weapons shatter Hittite bronze. Most dramatically, early steam-powered chariots, heavy, slow-moving vehicles more akin to tanks than traditional chariots, terrify enemy horses in break formation lines. In the aftermath of Kadesh, Ramesses doesn't merely negotiate a peace treaty as in our timeline, he dictates terms of technological subjugation. The Hittites are permitted to maintain political independence initially, but must accept Egyptian advisors who control access to strategic technologies. Egyptian factories are established in Hittite territory, operated by Egyptian engineer priests. Within a generation, the Hittite Empire becomes a technological vassal state, its rulers maintaining ceremonial authority while real power shifts to those who control the new industrial infrastructure. This pattern repeats across the Near East and Eastern Mediterranean. Rather than conquering and directly administering vast territories, Egypt establishes a new form of technological imperialism. Local rulers remain in place but must accept Egyptian industrial outposts, staffed by Egyptian personnel who maintain monopolistic control over advanced technologies. Access to iron tools, steam power, and Egyptian luxury goods becomes contingent on political cooperation. Cyprus, with its rich copper deposits, is one of the first regions to experience this new imperialism. Egyptian industrial colonies transformed the island's economy and landscape. Vast mining operations feed Egyptian metal needs, while forests are harvested for charcoal production. Native Cypriot culture persists but increasingly adopts Egyptian technical vocabulary. Religious concepts and social structures related to industrial production, Crete and the Mycenaean Greek world experience similar transformations. The palace economies of the Late Bronze Age Aegean, already engaged in complex trade relationships with Egypt, become increasingly dependent on Egyptian technology. Local elites eagerly adopt Egyptian industrial products as status symbols, then gradually acquire the knowledge to create their own versions, always a generation behind what Egypt itself possesses. As Ramesses' policy strictly controls the export of the most advanced innovations, this technological diffusion creates the ancient world's first recognizable industrial supply chains. Raw materials flow toward Egypt and its industrial colonies, finished goods and carefully controlled technical knowledge flow outward. Egyptian trade networks extend further than ever before, reaching the Black Sea, the Adriatic, even tentatively probing the western Mediterranean and Atlantic coast of Iberia. Egyptian artifacts from this period have been found as far north as Scandinavia, as far east as the Indus Valley. Around 1250 BCE, a new threat emerges that will test Egypt's industrial empire, the first rumblings of what in our timeline would become the Bronze Age collapse. A complex series of cascading failures, climate change leading to crop failures, population displacements, and systems collapse that would eventually topple most of the major civilizations of the Eastern Mediterranean and Near East. in our historical timeline, even Egypt barely survived this perfect storm, emerging severely weakened after fighting off invasions by the mysterious sea peoples and enduring internal instability. But in this alternate world, Egypt is far better positioned to weather the crisis. Its industrial capacity provides resilience against crop failures. Its superior military technology offers protection against migrating populations seeking new lands. Its diversified economy and energy sources make it less vulnerable to supply chain disruptions. As neighboring societies begin to show signs of stress, the Mycenaean palaces facing food shortages, Levantine cities experiencing internal unrest, Ramesses recognizes both danger and opportunity. He initiates a program of controlled immigration, allowing selected groups of skilled foreigners to settle in Egyptian-controlled territories in exchange for technical training and cultural assimilation. This policy provides a safety valve for population pressures in neighboring regions while strengthening Egypt's industrial workforce. The Sea Peoples, who in our timeline nearly overwhelmed Egyptian defenses in a series of massive naval and land battles, face a very different reception in this alternate world. Egypt's steam-powered navy, with its independence from wind conditions and superior speed, intercepts their fleets before they can coordinate massive raids. Some groups are destroyed. Others are offered settlement in specific territories as Egyptian client populations. Perhaps most significantly, the Philistines, one of the major Sea Peoples groups who would establish themselves in Canaan in our timeline, are settled instead in controlled circumstances as an industrial workforce in Egyptian copper mines in Sinai and Timnah. Their descendants become a distinct but integrated population within Egypt's industrial apparatus, eventually developing specialized expertise in metallurgy and mechanical engineering. As the 13th century BCE progresses, with other Bronze Age civilizations weakening under environmental and social pressures, Egypt's technological advantage grows even more pronounced. Regions that in our timeline would descend into a dark age with loss of literacy and complex political organization instead become increasingly integrated into Egypt's industrial sphere of influence. The power vacuum left by declining empires is filled not by fragmented local powers but by Egyptian industrial colonization. By the final decades of Ramesses' long reign, the world looks radically different from our historical timeline. Egypt stands as an industrial superpower in a way that would not be seen again until 19th century Britain. Its technological capacity extends far beyond anything the ancient world achieved in our history. Steam engines pump water, power factories, and drive ships. Iron is produced in quantities that wouldn't be matched until classical antiquity. Mass production techniques standardize everything from weapons to furniture to architectural components. The environmental impact of this early industrialization is already becoming apparent. Deforestation accelerates across the Mediterranean as trees are harvested for charcoal and shipbuilding. Mining operations scar landscapes from Nubia to the Balkans. The air over major Egyptian cities grows increasingly polluted with coal and wood smoke. The Nile itself, while still the lifeblood of Egyptian agriculture, shows the first signs of industrial contamination near major manufacturing centers, yet Ramesses and his advisors show surprising foresight in addressing these challenges. Reforestation projects are initiated in heavily harvested areas. Water filtration systems, drawing on Egypt's long experience with hydraulic engineering, help mitigate some industrial pollution. Most significantly, Egyptian engineers begin experimenting with solar power not through photovoltaics, of course, but through massive mirror arrays that concentrate the abundant Egyptian sunlight to generate steam without combustion. As Ramesses approaches the end of his unprecedented reign, he oversees an Egypt transformed beyond recognition from what we know historically. The population has more than doubled, sustained by industrialized agriculture and food preservation techniques. Cities have expanded dramatically, with specialized industrial districts and worker housing. A complex transportation network of canals, steam-powered boats, and improved roads connects the entire realm. Egyptian influence extends across the Mediterranean world, manifested in industrial colonies, client states, and technological vassals. Ramesses dies in 1213 BCE, as in our timeline, after 66 years on the throne, the longest reigning pharaoh in Egyptian history. But unlike our world, where his death would eventually lead to gradual Egyptian decline, in this alternate timeline he leaves behind an industrial superpower poised to dominate the coming millennium. His legacy is not just monumental architecture and military conquests, but the foundation of the world's first true industrial civilization, forged in the furnaces of Egypt. Powered by the steam of the Nile, and poised to reshape human history in ways that will echo through eternity, as the 12th century BCE dawns, the question is no longer whether Egypt will survive the Bronze Age collapse that devastates other civilizations, but how it will harness that chaos to expand its industrial empire even further. And as distant peoples, from the emerging Phoenicians to the early Italic tribes, from the nascent Israelites to the future founders of Carthage, encounter Egyptian technology for the first time, how will their own development be transformed by this radical alteration to history's timeline?